Inverse functions using tables. This is probably one of the more straightforward ideas with inverse functions. Anytime that you're given a function, it's going to be told to you if it's invertible or not, if you're just given a table. So it says the function f of x is invertible. That means that essentially x and y are getting switched. And whenever we get to the section about identifying inverse functions and finding inverse functions and relations, then that's going to be a way to undo a function, like solving an equation backwards to find the missing part. Now we can find out why the output was the way it was given whatever input, instead of given an input to generate an output. So that would be the primary idea of why you would want to do inverse functions. From a table, it's pretty simple though. So just a couple of examples to go through. We know that in the original function, x is going to be what the function is about, the function of x. Now, whenever we do an inverse function, that 18 is actually not going to be referring to the x value. It's going to be referring to the y value, the original y value. So whenever we have an inverse function, we can set it up like this. And the inverse is just going to be the opposite. So 18 and 9, 24, 30, 36, and 42. Then we put our x values on the other side. And what's happening right now is our y values are becoming the input and our x values are becoming the output. 15, 18, and 21. So the function of 18 is going to coincide with 9. And we know that because it was our input, just as the original f of x was. Now we're talking about the input being the y value and the output being the x value. So whenever it gets switched like that, all you do is find out what's associated with the new input. So the input would be 18, which is the y value in the original function. That's going to coincide with 9. So we know that in the original function, we're referring to x. That means in an inverted function, we're going to be referring to that as y, which is going to be our new input. So I always encourage you to go ahead and start with a table that just flips the coordinates, especially if it's telling you that it's invertible. So we're going to put the y values on the other side, -7, -6. Okay, so -12, -9, -6, -3, and 0. And again, this is a really straightforward way of understanding if you have a table for the original function and it's stating that it is invertible. The idea is that your x and y coordinates are switching. And what this is going to do is going to help us solve problems later. So now we're looking for if our input was -5, what would that coincide with? And that would be with -6. So it's a way to reverse the entire process. We know that the original function is going to be talking about the function of x, and this inverted function will be talking about the function of y, which is going to be our new input. So just for a third time, we're switching our x and y values. You can see all I'm doing is rewriting the table with the y values on the left and the x values on the right. -0, -1, -2, -3, -4. Okay, so when it comes down to what is the function of -3, well, all we have to do is look at our y values at -3 and find out what coincides with the output value, which is the original x, which would be 0. So just know, whenever you got a table, it states it's invertible, all you do is switch the x and y values.